Welcome everybody. In this video we're going to recreate AutoMapper using runtime code generation with Roslyn. It's pretty much a combination of source generators, reflection, and perhaps IL generation, an amalgamation of all of these approaches that we've covered previously. Links to all of those in the description, go ahead and check them out. We have quite a bit to cover, so let's go ahead and get started. Just to give you an idea for the setup of the project, we got the two classes, probably the most straightforward thing. And then we have the Microsoft Code Analysis C# package installed, and that is pretty much it. By now, writing the mapper itself is pretty straightforward. So what we're gonna first do is we're gonna print hello world from the code that we generate, and then the mapper will kind of be placed on its own because we've written that logic like 1,000 times. So the way that you work with this is you do something along the lines of this. You create the code. Let's give it an @sign. We will give ourselves a using statement, right? Using system. We'll give ourselves a namespace. I'll just call it gen. I will then create a public class, my class, and I'll give some curly braces here. And then a public static void print method. I don't want this to be an interpolated string. I will then grab this console write line. I'll place it into here. And that's pretty much what I'm after. So I have my namespace, my using for the console write line, and if you've done source generators, you should be pretty familiar with this, because if you're using string builders, this is kind of what you're going to try to replicate. What we want to do now, we have the text file with our code. We want to go ahead and use a C# syntax tree to parse this text into what essentially is a bunch of C# objects representing each one of these tokens. So we just put our code back in here. We get back our syntax tree, which is, well, just a tree of objects representing this code. We then use the C# compilation to go ahead and compile this tree. Now you can compile to many different things, DLL, executables. We're going to be outputting a DLL. First you do the compilation and then you go ahead and spit it out somewhere. So file, memory stream, we're going to be using a memory stream. We don't need to actually output the DLL, but that's the direction that we're going in. So first parameter is the assembly name. This doesn't really matter too much, so I'm just going to put in gen. For the syntax tree, we can supply multiple ones. So I'm just going to go ahead and put in my single syntax tree that I have. Let me spread this out a little bit. We are then going to have to add some references. So these are metadata references. We're going to find out what that is in just a minute. And then we can supply some options. The options specifically can let us say what kind of output we want. Let's say we want to output a DLL. This is what we specify. Let's get rid of this lengthy class name. And there we go. So this is going to give us a immutable object that represents the current compilation context. So compilation, we then want to emit, and this is where we either emit to a file or a memory stream. Specifically, we're going to be using a memory stream. So var ms new memory stream. Let's go ahead and it doesn't really matter too much. We're just going to put a using statement in there for lols. This is going to give us a result. And on this result, like a general validation result, we can check if it's successful. If it's not successful, let's go ahead and return. And we're going to crash for a little bit just so I can explain the meta references and what they are. And if you are using this approach, what you have to do. But in the result, we're going to have the diagnostics where, yeah, this is basically when your code doesn't compile, this is what you're going to see. It's just going to be a bunch of errors. So let's go ahead and get the message from the diagnostic. And this is if we are unsuccessful. If we are successful, let's go ahead and reset the memory stream, because when we write to it, it will have an internal position or a pointer. We'll want to go ahead and seek write to the beginning. So offset 0, and we're going to be at the beginning. So when we read from it, we read from the beginning. We then want to go ahead and load from a array of this memory stream, and this is going to be an assembly, right? Inside of this assembly that we've just spat out is going to be this type. We can go onto the assembly, we can try to get a type, go into our namespace and load our class. Here is the type. If we didn't have a static method, we can use the activator to spin up an instance of my class, but we're not going to do this. We can just go to invoke member. We are going to invoke the method print. Some of the binding flags that we have to specify here is, I can't spell out binding flag, so let me just grab it again. And invoke method. We then on the object that we basically static method, so we don't supply the object, null null, and no arguments either, another null. We don't return anything, this should just print hello world. And at that, let's go ahead, close type, open up a terminal, and just run this. What we're seeing here is essentially the console write lines at this place where we are failing to emit our dynamically linked library because we don't know what object void is, what a string is. We basically don't know anything. We can kind of understand the C# syntax, but we don't have the basic tools. And this is basically where we need our metadata references and reference to the C# SDK, kind of the core library. So metadata reference, you can create these from files. Files of the core library can be found by looking for a type of object. So it's going to be some type. It's going to be contained within an assembly, and that assembly is going to have a location. So we're going to load it from there. We're kind of curious where this location is. So let's go ahead and assembly path. Assembly path is pretty generic, so let's just call this core assembly, and this is not a path, it's gonna be its location. Yeah, so that will be good. Let's go ahead and load it from there. We're going to run this again. The error is going to change, and that's because we're going to be missing console, but actually what I wanted to do is I wanted to output this core assembly just to show you the contents of this folder, just so you know that what we're looking at. So let's go ahead, grab this path. I'm going to go to this folder, and here you're going to see basically a bunch of DLLs of which the C# SDK comprises of. Your system.net DLL, this is where your HTTP client is, everything that you use, the strings, everything basically. Part of it is this system.private.core_lib, which yeah, I can only assume is like the core of the whole C# SDK. But nevertheless, we are still wanting to surface the console because it's contained in system, but we don't have some kind of reference to this console, right? We're only referencing the core. We're only referencing this DLL. We're not referencing something like system.console. Where is it? Right there. So let's go ahead and do the same approach that we've done here. So I'm going to duplicate this line. Instead of core assembly, I'm going to supply type of object. And this time I'm going to try to reach console. Let's save that, and I'm going to rerun this. This time we're still going to be missing some kind of reference, but we're going to be missing a reference to system.runtime. So let's go ahead and try to do the same here. And this is where, you know, a system.runtime is just a namespace. We will need a little bit of help here. And if we take a look back into this folder and we abcdefghijklmnopqr, we will find system.runtime.dll. So let's just grab its name, and if we come back here, we want to grab the first path of this the first part of this path. That's what we want to grab. So let's go ahead to this core assembly right here. We will say base assembly path. This will be a path, and we will get directory name from the core assembly location. We can do a path combine here. So we will combine base assembly path with the name of the DLL, and yeah, basically at that point we should be able to, well, point to it and load it, or rather reference it. And there we go, at the end we have our hello world. So this is pretty much the initial setup that you have to go through. You kind of have to write your code, or, you know, as we're about to do now with the mapper, we're gonna write our logic that kind of generates this string, and then you go through this process of, I want to parse it, I want to make sure whatever classes I'm loading their relevant locations. We're not going to be using console write line, so we're going to be removing some of this stuff. But pretty much you want to compile it, you want to load it into some memory stream, and because, well, just keep it in your application and then just load it in as a C# object and then extract types from it to do whatever you need to do. So let's jump to the top. We're going to start, or try to start, a little bit more simplish. We will do type of A, we will get our properties. So these are from props, Could probably lift a lot of this code from the reflection video. These are going to be 2 props. We're then going to have a string builder, which is going to make things a little bit easier in creating this whole thing. Then we want to go ahead and append maybe about yay much, which is the first part of this really, and then append the last bit of this, so about yay much, without actually, it's just going to be the closing curly brace. Put a semicolon on the end. The code at the end is going to be sb2string, and we can actually exclude it altogether and just pass it to parse text here and remove the code variable. Let's duplicate the append. We are going to start with public static. We'll make sure to append a little extra space here. We're going to start with type of B. We're going to get the name of the type, or we can probably get the full name. So let's actually use that. It's going to be a little bit verbose, but it'll be good. We will then create the function name, so we'll put a space because that's not going to have a space. We'll call it map, we will open, and again we'll just supply the type, which is going to be A, which is going to have the full name. We will then give it a variable name, like from. We'll close off, open up the curly brace, make sure that we close it as well. And actually, if we want to be, you know, a little bit spicy, let's just put a semicolon here, and we're going to go with an arrow expression. We'll just say new object whatever, put a curly brace here, a curly brace here, and then we want to append our parameters. So from props, create a for each loop. This will be a from. Kind of similar, well, not kind of, very similar. You could probably remember this being typed out from previous videos. The logic is pretty much the same. It's just the setup is always kind of different. Well, not kind of, it is different. Again, if 2 is null, I'm kind of, you know, as I'm typing it out, you know, I'm kind of thinking over what I just said, and I'm like, that really makes sense. And this talk is not really contributing that much to this video. Will I cut it out? Will I leave it in? I don't know. Did you enjoy this part of the video? Tell me what you think in the comments. But yeah, we want to go ahead and append. We want to grab the 2 name of the property. This should be equaling. So equals, and it actually equals from. This isn't, it can no longer be a character. And we are going to again select the from name. Let's not forget the semicolon and then a comma at the end that we actually don't have to pop from the string builder. It's okay if there is a trailing comma somewhere there. If I am paranoid, what I can do is I can actually just dump this to a file and see what I have generated. So we'll save this. If we run into a problem, we'll debug it. If we don't run into a problem, we don't run into a problem. So this looks good to me. Let's call this class mapper. We can also maybe make it static. Okay, so we have our built up version. Let's slide down here. We're now going to grab our mapper. So this is more of like an internal mapper type, or map method generator. We are sort of pre-generating this code, but we can also be generating code as we're sort of launching these types into the AutoMapper that we're about to build. But this time we are invoking a map method. That is what I called it right here. We then want to supply 1 argument. This is going to be, let's just take it out somewhere here, arg, or args, but you know, I already have args in the global namespace, so let's just give it a cool name. I'll say a new A, we'll have ID 1, and then name foo. We're gonna get a result on the back of this, which should be B, and we should be able to cast this. And then by the end of this, we should be able to call console right line, the identifier, and then the name. Let's go ahead, put something like this here, missing a bunch of spaces, but there we go. Let's go ahead and rerun this. So this is an okay error to basically encounter. Again, if you remember from the beginning of the video where I kind of said why metadata references were important, this is again, we're running into the same issue where we are referencing, we're even trying to navigate to the full name of this namespace, and we just don't understand where this or what this namespace is at all. So this is where basically, if I go ahead and reference AutoMapper in runtime generation, if I fully type out the namespace and I don't have a reference to the package, it's still going to be like, I don't know what AutoMapper is. It's not part of the standard library. So I still, I have to reference it. So we're no longer using any of this. I'm just going to leave this in here for completeness sake, because it's not going to be part of what's called the Git history. So if somebody wants that as an example. But let's go ahead and get type of program. So this current assembly, the invisible program class, and let's rerun this. Oh, my bad. It looks like we, what's it called? We lost the reference to system private core lib. So let's actually core assembly location. Let's import that back. And there we go. One name of foo of type B. So, oh, looks like the conversion has been pretty successful. Let's try the standard test. So word is word, and this time, we'll be sensible and we will call body body, not something like or something like that. Let's go ahead and rerun, and no change, but a standard mistake. I've done this in maybe all of the previous videos as well, so to be expected. There we go. We see the word, and word comes from being on the B class. If we actually rename the body to word, we should be able to see body being printed in the place of word. And there it is. So now the last bit, a little bit of caching. We want to be able to have a little bit more of a friendlier interface rather than this whole malarkey here. So let's go ahead and create our public class mapper. This can be static. I'm just gonna create static whatever. Oh, this is not Java. Team. We're gonna, again, same thing, object. This is going to be from static void. I will call it do for now because I'm doing a little bit too much. Same as before, we're gonna give it a little bit of cache, private static dictionary. I'm not writing optimized code straight from the get-go. I will optimize it for benchmarks to my best ability, and then if other people want to contribute optimizations to see what kind of juice we can get out of this, let's go ahead and do that as well. But there is the cache from to the final type that I'm gonna get the invoke member on. So same as before, I'm just gonna start with creating a key. This is going to be my tuple. So from is going to be type of, from get type. And one too many braces. 2 is going to be type of t. If cache contains key, not. This is where we want to go ahead and populate cache. Populate the cache key. We're going to go ahead and send this key down into here. And actually, let's just grab this type right here. We will just mark it so it's a little bit easier and a little bit easier to read. Yeah, there we go. Key. We will need maybe around from mapper type. Yep, so mapper type is the entry that we will store in the cache behind the key. So from here, all of this stuff. So from to, yep, all of that. Let's put it into this method. I'll quickly format this, but type of A and type of B, let's go ahead and replace these with key and from, and then key to. Let's just make sure I'm not using anything else here. So again, so type of B, this is actually to. Type of A, this is from. Again, quick format. From to type of object, that is something completely different. No longer or no more type of A or B left in this function. Let's go ahead and store the type that we generate in this cache. So this mapper type will go cache. And rather than dot, let's just go ahead and insert the key and put the mapper type in there. There we go. So if we don't contain anything, let's go ahead and populate cache key. We'll put the key in there. And then finally, we can actually just invoke this on the mapper type and cast it to the correct thing as well. So let's go ahead and say cache key, grab the invoke member thing, place it over here. Nope, it looks a little bit wonky. Let's spread this out. Args, we can still have args, I think, with actually the parameter coming from there. Let's preserve the A. I'll just put it over there. I'll put this array over here, and the from object can go into there. I'll just format this a little bit again. Looks like that's it. We don't need this. We can go to our mapper. We can go ahead and map to B from A, semicolon on the end. Don't need that. And let's rerun this. Let's make sure that this works. And well, there we go. In the end, basically the approach of, using a string builder to build up your C# code isn't too complicated, really just digging out the information around this initial setup. Cool little thing to know. Otherwise, this will be it for this video. Remember, there's going to be one more video for benchmarks. So if you're not subscribed, go ahead and subscribe. If you like this video, you know what to do. If you have any questions, make sure to leave them in the comment section. Big thank you to all of my patrons. Thank you very much for your support. It does help a lot. If you're not supporting me, please consider. Otherwise, thank you very much for watching and have a good day.